In this video, we're going to be going over how to use the elimination method to solve a system of linear equations when we have to multiply one or both equations by a number so that we can make the elimination happen. So we're going to begin with our first example, which is x plus 2y equals 20 and 2x plus y equals 19. Notice that neither of them match. Neither of them are opposites. But we can do it pretty easy by multiplying our top equation by a -2 to all three things. So if we do that, that's going to give us a -2x minus 4y equals -40. Then we'll write our second equation underneath it, and we're ready to add. So as we go to add here, we see that our x's eliminate just as we wanted, giving us a -3y equals -21. We divide both sides by a -3 to give us a y equals 7. And we're able to take that 7 and to plug it into either our top or our bottom equation. It doesn't matter. Either one will give us our x value. So we're going to plug it into our top equation. I just feel like doing the top one. So we're going to plug the 7 into the y's spot, giving us x plus 2 times 7 equals 20. So we have x plus 14 equals 20. And now we're going to subtract 14 from both sides to get the x by itself, giving us x equals 6. So our solution here is 6, 7. Now you'd want to make sure that you plug that into your top two equations, those points in, to make sure that they work. I've already gone ahead and done that, and our solution, in fact, works. Now, if you want a refresher on how exactly to check those ordered pairs, you can look at our other video that says solving systems by graphing and how do you know if it's a solution to the system. Let's take a look at letter B. Here we have 3x minus 2y equals -2 and 4x minus 3y equals -4. Notice we don't have any matching x's or y's, and we don't have opposites either. So in this case, we just want to make a decision as to should we get rid of the x's or should we get rid of the y's. It really doesn't matter. It's kind of like a personal choice of what you think is going to be easiest. I'm going to go ahead and I'm going to stick with the x's. So what does 3 and 4 both have in common? Well, they can both turn into the number 12. So we're going to multiply our top equation by 4 to everything, and we're going to multiply our bottom equation by a -3. Now I chose the bottom to be the negative just because it was the bottom equation. I did the positive first. I could have very easily multiplied the top by a -4 and the bottom by a +3 and still gotten the same answers. So we're going to go ahead and if we multiply our top equation to 4 to each piece, we get 12x minus 8y equals -8. And if we multiply our -3 to each piece, that's going to give us a -12x plus 9y equals 12. From here, we're able to add our equations, and we see that we eliminate our x's as we had hoped, giving us y equals 4. Now, we already have the y, so we can just plug that right in. I'm going to go ahead and choose the bottom equation this time to plug in the 4. So here we have 4x minus 3 times 4 equals -4. And we're going to get 4x minus 12 equals -4 from that. So we'll add 12 to both sides, giving us 4x equals 8. Then we'll divide both sides by 4 to get x equals 2. So that's going to give us a ordered pair of 2, 4, which we'll want to plug in and check. And again, I already have, so we get 2, 4. I want you to try letter C on your own and see how you do. So go ahead and push pause. If you're done with the problem, push play, and let's see how you did. So here, our x's are already very close to being the same. In fact, we could just get away by multiplying our bottom equation by a -3. So we'll go ahead and we'll write down our top equation, 9x plus 4y equals 11, and then we'll distribute that -3 to all of the pieces of our bottom equation, which will give us a -9x plus 30y equals 6. From here, we'll go ahead and we'll add our two equations, and our x's will cancel out as we had hoped, leaving us with 34y equals 17. From here, we'll divide both sides by 34, giving us 1/2. And it's okay that we have a fraction. That's not a big deal. You can use your calculator to help you if you need to. So we're going to go ahead and we're going to plug this in. Because both of my y's are even, I'm not too worried about which equation that I pick. So I'm going to choose the top equation. So 9x plus 4y equals 11. And we're going to go ahead and we're going to take out the y. And that's where we're going to put our 1/2 that we got. So now I have 9x, and 4 times 1/2 is a 2. So 9x plus 2 equals 11. I'll subtract 2 from both sides and get 9x equals 9. And when I divide both sides by 9, I get x equals 1, leaving me with a solution of 1 comma 1/2. And when I plug that into both of my equations, I see that they work, meaning that my solution is 1 comma 1/2. So here we have how exactly to eliminate using the elimination method. When we go to solve systems of linear equations, and these were pretty basic, not too difficult as far as multiplying. Probably B was our hardest one here. If you want some more practice with some problems like B, then go ahead and watch our other video that is part 2 of solving systems by elimination.